Good morning, everyone, and thank you for joining us for WECC's Resource Adequacy Discussion Series. Today is the fifth part of our series, where we'll be discussing Western heat domes. The date is November 2nd, and it is 10 a.m. Mountain Time. I'm Travis English. I'm WECC's Senior Training and Outreach Specialist. And we're going to take a quick minute to talk about a survey that we'll be doing. This QR code that is on your screen right now, you can take a photo of that with your smartphone or use the link that's coming to you via the chat to complete a survey about the Resource Adequacy Discussion Series. We're asking stakeholders to share your thoughts, possible topics that you'd like us to cover in the future. And it's a quick, short survey, so we invite you to take that. Again, you can take a snapshot of that QR code or use the link in the chat. We appreciate the feedback. And then WECC is excited to announce that we released the Western Assessment of Resource Adequacy today. This is our annual report. It was released just this morning. I believe a link just went out in the chat where you can access the full report. More information is also available on WECC.org on our homepage under the announcement section. Something to note, we'll be talking next week on November 9th at 10 a.m. We'll be talking about the Western Assessment. We'll be taking a high-level policy look and review of the assessment itself. And then the following week on November 16th, we'll be taking a deeper technical dive into the Western Assessment of Resource Adequacy. So mark your calendars for that. I believe more information is available in the chat on where you can access the webinars. And as always, we'll be providing updates in the WECC weekly news about the Western Assessment. So excited to announce the release of that today. We'll start off with WECC's antitrust policy. All WECC meetings are conducted in accordance with the WECC antitrust policy and the NERC antitrust compliance guidelines. All participants must comply with the policy and guidelines. This meeting is public. Confidential proprietary information should not be discussed in the open session. This webinar is also being recorded and it will be posted publicly. By participating, you give your consent for your name, voice, image, and likeness to be included in that recording. WECC strives to ensure the information presented today is accurate and reflects the views of WECC. However, all interpretations and positions are subject to change. If you have any questions, please contact our legal counsel. A quick look at the program today. We'll have an introduction to the topic of Western heat domes and resource adequacy with WECC Board Director Gary Leidich, and then we'll go into the panel discussion where we'll have moderators Kris and Tim Reynolds from WECC, and we have panelists Kris Hofmann from Salt River Project, Richard Hydzik from Avista, and Dede Subakti, from the California ISO. So excited to have those panelists and Director Leidich on the call this morning. And with that, we'll jump right into the program and get into that introduction with Director Leidich. Director Leidich, I turn it over to you.
Thank you very much, Travis. It's great to be with you this morning. And let me begin by also thanking the WECC staff for putting this whole program together. I think it's just been outstanding. And it's great to have many participants as well as what we're doing today with our panelists. And I appreciate you folks coming out as well and helping us out here. You know, resource adequacy is a top priority for the WECC board, and it really is across most of the regions in the country here. You know, there are many factors. The changing resource mix is probably the most dominant factor in terms of our concerns about the resource adequacy. The policy for decarbonization has kind of led the pack in that regard. And the good news is we're making progress there. Just as a data point, historically, about 50% of the generation in the United States has come from coal-fired generation. Last year, that number was 22%. So we're making progress in that regard, but it does impact reliability, as we've all seen. The other thing that's emerging quite a bit is electrification. Now, whether it's electric vehicles or improved technologies in manufacturing, we do believe the load's going to increase, and that may exacerbate the situation as well. And of course, the final factor in resource adequacy is the one that we're here to talk about today. the weather. And unfortunately, it's the one that we can control the least. Weather's been with us all along, obviously, and it's impacted the utility industry for the last 100 years. We've had storms, tornadoes, hurricanes. In the Midwest, we've had ice storms. I'm old enough to remember that we derated coal plants because of frozen coal piles. Imagine that. So it's been with us, but I think we would all agree that things are changing. The weather events have become more severe and they've become more frequent. And in fact, we kind of have a new vocabulary with all these events. Let's go back to 2018 in the winter, which was a pretty harsh winter for us here in the US and particularly in the Midwest. Terms like polar vortex and bomb cyclones. Now, I don't know what those are, but the weather folks have invented these terms as unique to the extreme weather situations that we've seen. In fact, we had outages here in the Midwest. We had high prices. In New England, they've used oil-fired generation in some periods due to lack of natural gas. So it's kind of all over the country. And as a result of that, we are offering what we're talking about today in terms of the Western impacts. The other phenomenon that I've heard, which is another new term, is weather whiplash, and this is drought followed by flooding, followed by drought, followed by flooding. We've had several of these events here in the U.S. this year. We're all familiar with the droughts and the impact on generation, hydro generation in particular. We've seen that out west in particular. This summer we had, and I find this pretty interesting, we had 5 1,000-year floods. So just think about that for a minute. I don't think it'll be 1,000 years before we get those again. 4 out of those 5 here in the U.S. occurred right after significant droughts. Same thing in China, Western Europe, Pakistan. It's all over the world, really, in terms of the global impact. And at the other end of the spectrum, we should remember the tough event in Texas, not only the loss of electricity, but natural gas, water supplies as well. So it's been tough, and the weather is impacting us more and more every day. And today, that's what we're here to talk about, particularly on the heat side of it. More lexicon, heat domes and heat waves, and our panelists will explain those things. But our overall focus is on high levels of reliability and making sure that our customers get the reliability that they're accustomed to, that they expect, and that they deserve at a reasonable cost. So our focus today will be on the operational side of it with folks that live on the front lines and have gone through these events. Whether it's curtailments on a voluntary basis or on a mandatory basis. Some parts of the North America use price signals to get through these events, so we'll have discussions about those things. And then secondly, on a planning perspective, do we have the right standards and the right models to be able to deal with these kind of events? And just as a bottom line, the bottom line of this whole thing is, as we look to the future, are these extreme weather events really going to become a kind of a new weather normal for us? We all talk about normal forecasts and normal weather, and you got to wonder if this is going to be going forward sort of a sign of the times. So again, I appreciate the opportunity to be with you, and we'll get into the panel discussion. With that, I will turn it back to Travis.
Great. Director Leidich, thank you for that introduction. I appreciate that and appreciate you coming on to welcome everyone. Before we jump into the panel and I introduce the moderators, I want to let the attendees and audience members know we'll be taking questions throughout today's panel. So use the Q&A chat feature on the right-hand side of your screen, and you can put those questions, and we'll be answering questions with our panelists throughout today's presentation. So I encourage you to have that open discussion with the panelists and our moderators. With that, I'll bring the moderators in. We've got Kris. She's the Vice President of Strategic Engagement and External Affairs here at WECC, and Tim Reynolds. He is the Manager of Event Analysis and Situation Awareness here at WECC. Tim and Kris, I turn it over to both of you.
All right, Travis, thank you for the introduction there. So we are really excited today for our panelists to be able to do these conversations with us today. As Gary had mentioned, they've been on the front line. Really looking forward for them to sharing their perspective on things and with these heat waves and heat domes, as was mentioned, that have occurred here within the Western Interconnection. And right before I introduce our panelists, I do want to cover on that topic just very briefly on what exactly is a heat wave and heat dome. And so just to let everybody know, just very briefly about these two terms, a heat wave is really a period of abnormally high temperatures, more than normal maximum temperatures that last for several days. A heat dome is when the atmosphere traps hot air like a lid or a cap and causes those higher temperatures and everything else that we've also been seeing. But I just want to let everybody know, don't get fixed too much though on these terminologies. We will be going back and forth between the two. Again, don't fix too much on them as much as just the discussions and the lessons that are being provided by our panelists today. So that is mostly the focus of it. But again, those two terms will be interchanged throughout the whole discussion. So let's go ahead and start out. Our panelists today, we do have Kris Hofmann from Salt River Project. He's the Director of Transmission and Generation of Operations, as well as Rich Hydzik from the Avista Corporations. He's the Senior Transmission Operations Engineer. And also Dede Subakti from the California Independent System Operator, who is the Vice President of System Operations. So thanks everybody for being here today and for being able to share your expertise and your experiences with us. That being said, let's go ahead and jump right into it. So Kris, let's start with you. So in the early part of September this year, we experienced a heat dome. And in case those attending that don't know, we also set a new interconnection peak demand record here in the Western Interconnection. And Kris, can you talk to us about some of your experiences during this past heat dome?
Yeah, you know, we were looking kind of ahead of this year, this summer. We were working out there. Our teams were securing additional generation imports just to support that. We actually ended up peaking a little bit later than normally. So we peaked around July, about beginning of July. But then from a stance of, we saw the heat kind of growing pretty quick in the June timeframe, May timeframe. But then we ended up getting hit pretty strongly with monsoons. So we peaked out on July 11th, and all of a sudden our loads kind of dropped down tremendously because of those monsoons. They did us a huge favor, but we were pretty prepared from the resource adequacy side. So we were able to help support other neighboring utilities, our neighboring BAs, and support that. Honestly, you know, when those monsoons hit, that put us in a little bit of a pickle. I think between ourselves, APS and WAPA, we lost about 5 230 kV lines throughout the system. So it made it a little bit tough, but you know, all the Arizona utilities really work well together, honestly supporting each other as much as possible. So yeah, we had a pretty mild, semi-mild experience from resource adequacy side, but got smacked around pretty good from the monsoon side this year.
Okay, thank you for sharing that, and glad to see that the cooperation between, you know, where you're at and APS and WAPA, it's always great to hear those success stories of everybody working together. Dede, there in California though, it was a little bit of a different experience. Can you go into that for us?
Sure. Thank you. So I think many of us heard and know that in California we had a very long, I guess in your term, it's a heat wave. It started from August 31st, and then it goes to September 1, 2, 3, 4, 5, 6, and that was the peak for us was September 6th. We reached to 52,061 megawatt. And when we think about 52,061 megawatt, that is, I think, 2,000 megawatt over and above what we previously ever had. And just from a perspective, our 1 and 2 load that we normally expected, our energy commissions would forecast for September 1 and 2 load is about 45,000. And so we reached 52,000 megawatt. That is about 7,000 megawatt additional above and beyond Nevertheless, I think we made it, but definitely resource adequacy capacity alone was insufficient to cover both our gross peak and net peak load on September 6th, and that's because of by design, right? By design, the resource adequacy capacity is looking at the 1 and 2 peak load for the month, which is about 45,000. You add the PRM is the planning reserve margins 15% roughly. So the resource capacity margin resource adequacy capacity that we plan coming into the month was about 51,000. And when you think about it, that's the resource adequacy that we had coming into the month was about around 51,000. And then you get the load at 52,000. So definitely we relied on a non-contracted capacities to get through the 52,061 megawatt of peak on September 6th.
All right, thank you for sharing, Dede. One thing I want to talk about though too is, as you said, which you have to rely on contracts and possibly your neighbors. What are some of those things that causes you to kind of stay up at night if something bad were to happen with those connections with everybody else? For instance, is it wildfires or just kind of severe storms that might trip those lines out? Can you expand on that a little bit?
Sure thing. So yeah, so in our resource adequacy construct, we, like I mentioned, we plan for the peak forecast plus the PRM. So that's roughly about 51,000 megawatt. But there's actually some internal generation, and there is a number of import in there. Now this year, actually, the contracted import is actually less than what we had before. So the reliance of import is a little bit less compared to the previous year. But of course, when we get this import capacity, you need a transmission line, right? The wildfire is one of those things. Fortunately, we did not have a wildfire during that September event, but people always think about what would happen if there's a potential wildfire that is going on. But also the other portion is the transmissions congestion in other BA. So for example, we've actually noticed this, and there were a few moments where the resource adequacy import that is supposed to come to California, it's actually being curtailed and congested in some other area. We've actually noticed not a lot, actually just a few hundred megawatt, but there were resource adequacy resources that is contracted for load serving entity within California. It actually did not make it to California because of a curtailment that occur and congestion that curtailment elsewhere in the system. So when you look back and into the wide area view, when we have I think in September 6th, there were about 5 or 6 BA where there were in EEA, and there were some internal congestions within those BA that resulted in that curtailment. Then we don't get that resource adequacy that is already, even though it's actually contracted, it gets curtailed elsewhere because of that transmission congestions.
All right, thank you for sharing, Dede. And for those listening as well, as Dede mentioned, there's something called an EEA. That's an energy emergency alert. And so within the standards that the electrical companies have to follow, depending on their function, when things start to get really tight for them, when they're not able to have enough generation to meet their load demand, there's some emergency things that they can do. And there's 3 different levels to that. We're not going to go into the specifics, but these are some steps to allow them to be able to free things up to try to meet that load demand before, unfortunately, the last thing that happens is where you might have to shed load and customers to be able to help the integrity and the health of the interconnection as a whole. Kris, I do want to go back to you just momentarily. You did say that there were, between you, Arizona, and WAPA. Can you just describe a little bit of what those successes were that you were doing as far as that coordination?
Yeah, absolutely. And I actually left off Tucson Electric. They actually came up to help support as well. They were out working on one of the lines, a sub-transmission line that we lost that placed us all in a little bit of a challenging spot. We lost one of the sub-transmission lines to the wells out at one of the generation sites. So they were focusing on that. From the stance of coordination wise, our crews help support each other. We were supporting APS. APS was working with us, same with WAPA, doing whatever we could to remove the challenges or any risks to the most amount of customers, try and secure that system. If that's where you're headed down, Tim, sorry.
No, that's fine. Just looking for you to share some of those experiences and lessons learned that we might all be able to benefit from. So I do note that everything we do, communication is usually the key amongst everybody on all of this. Kris, I see that you have a comment.
I want to jump in really quick. First of all, can I ask Kris, Dede, and Rich to turn on their cameras and leave on their cameras, please? Just because as panelists, as questions come in, we're going to want to throw those around to y'all. And I don't think bandwidth-wise that's going to impact us in the least. Thank you. I appreciate that. I like to see who it is that we have on and that are part of these discussions. I know we haven't gotten to Rich yet, but I want to specifically ask a question of Dede. You talked about imports, Dede, but what about demand response in these heat dome events and these heat wave events? Because I know you and I have talked in the past and even in preparation for this panel, and some of the distinctions, I won't call them differences yet, the distinctions are that I don't know that you would have commissioners in every state that would agree that demand response is an RA product, right? That demand response certainly is terrific in an emergency situation. And I think California recognized that in spades this past summer when they utilized those emergency alerts to their to all of their users. But how does demand response play into the consideration of operations and even planning for utilities or for CAISO in this new environment that we're in, where we, within the West at least right now, RA is an issue?
Yeah, thank you so much for that questions. And maybe I'll go back a little bit in the explaining the resource adequacy program within the state of California, especially the one that is that we're managing in California. So I think I mentioned coming into September, we have a load forecast that is the 1 and 2 load forecast, and that 1 and 2 load forecast is about 45,000, and then we add the PRM, which is roughly about 15,000. So that's about 51,000 ish. Right, 51,000 megawatt capacity that we should procure, so to speak. Now, in the state of California, we actually have a credit program. The credit program is basically include demand response, includes stuff like reliability demand response. So the reliability demand response, for example, in the September 8, we actually have about 800 megawatt reliability demand response, and there's some other credit. So that actually taken off the top, and it's actually counted at our resource adequacy. So let's say that in this credit that we have there's 800 megawatt of reliability demand response. So the way that the resource adequacy program works in California is that if you have 51,000 megawatt resource adequacy requirement that you have to purchase, but you have 800 megawatt of reliability demand response, then you actually only need to procure physical capacity, which is 50,200, whatever the number is. But basically, demand response is actually counted as a resource adequacy in the monthly planning that we do in California ISO, and that demand response has actually become accessible to us in California ISO as a system operators when we go to EEA 2. So when we get into this energy emergency alert number 2, and we basically say, oh, okay, we get into that positions, and that demand response is actually already credited, and some of the demand response actually get a capacity, credit in there, and I, as a system operator, have the ability to then utilize it. And we did utilize the reliability demand response during an EA2, and that was actually come up about 800 megawatt, and that is a resource for us, and in the whole construct of resource adequacy demand response, California ISO is definitely counted and play quite a bit of a role in there.
Thanks, Dede. Tim, I'll pass it back to you for the hard work. I'm just going to pepper in questions when I want answers to particular things. I also want to encourage Gary, though, our director, who so willingly opened up the dialogue for us to insert himself whenever he would like with questions for our panelists.
Careful with that, Kris.
That's why we brought you, Gary. That's why the invite was extended.
Okay, thank you, Kris. And yes, please feel free to chime in and ask questions at any time. So one thing is, again, Kris and Dede, thank you for sharing that information. What I want to do, though, is we've kind of talked a little bit about the 2022 heat dome here, but I want to work back a little bit and start talking about what happened in 2021 and also in 2020. But I want to start with Rich first. So back in 2021, there was a heat wave that occurred mostly in the Pacific Northwest, here in the Western Interconnection, and it impacted that region quite a bit. Can you tell us about the experiences that you went through?
Sure, Tim. So back in late June of 2021, the Pacific Northwest experienced extremely high temperatures, outside the norm, as you mentioned. In Spokane, I think our record high previously had been about 105 degrees, and we were up at 109 for 2 days, the 28th and 29th of June. So, it was a bit warmer. Our typical summer peak, 100-degree day on the 4th of July weekend is very common. So, it didn't come very early. The heat didn't come so much early as it was just intense and sat there for a few days, and so our summer peaks are typically late July, early August. So early July is not unusual, but this one was. We hit our all-time peak. Being in the Pacific Northwest, typically our winter peaks are about 5% higher than the summer peaks, and quite a different load characteristic. VAR control becomes an issue for us in the summertime, particularly due to air conditioning load. In the wintertime, it's mostly electric heat and lighting. That's the bulk of the load. So we could go through the whole winter without a single capacitor probably and never notice it. But in the summertime, we would be, those motors would be stalling. So different change there. The other thing that we run into in the summer is our summer ratings, conductor ratings, temperature transformer ratings, and that sort of thing are far lower in the summer than they are in the winter. There's about a 35% drop between our winter ratings and our 104-degree Fahrenheit or 40 C summer ratings. So, that becomes an issue at times with certain equipment. So I'm going to frame my remarks. I know that this entire discussion is about resource adequacy. This happened in late June, a time of the year where even if it's hot, the Pacific Northwest generally has fairly good resources available if it's a normal hydro year. We did not run into a supply issue anywhere. We had adequate energy and no real transmission problems. Well, we did have a few, and I'll get to those. But our real concern was our distribution system was very heavily taxed in certain parts of our system for this. We had never seen these kind of loads on the distribution in the summer. Between 2019 and 2020, I think we snuck about 5% additional load onto our system that kind of flew under the radar because we had a large industrial drop at the same time. So the total BA numbers didn't change. But the fact they didn't change with that large industrial going away kind of indicated there was far more load out there than we thought. So our biggest concern, our biggest problem we had on the 28th was feeders reaching their maximum thermal limits and transformer hotspot CTs giving us alarms. So Avista's stated policy is if we get what we call a transformer major alarm, which can be several things. It's typically loss of cooling, hotspot winding, that sort of thing. The transformers reach this operating temperature and you're looking at loss of life if you leave it in service. We'll take them out of service under those conditions. And we had three transformers suffer those issues. One was actually loaded to the point where the hotspot CT flagged an alarm. We reached the temperature limit. The other one, unfortunately, was an uncalibrated winding temperature alarm that came in when the transformer was not fully loaded, and we dropped a large part of Southwest Spokane with that one. But I have to credit the operator. Hey, I'm going to protect this transformer. If I lose this transformer, we are really out for quite a while. So I got to give him credit for that. And then we had another one that was a similar issue. So this actually gave us quite a few problems on the first day. We ended up dropping almost 52 megawatts of load through the day. It was as much as 50 megawatts at one point, and our total system load for the day was 2,380 megawatts. So for most of the system, it wasn't really an issue. For particular feeders and areas in town, it was. We learned a lot on that first day. And on the second day, with similar temperatures and similar load, we only ended up dropping 5 loads on very targeted feeders. We did do some public appeals on both days, actually for about 3 or 4 days. I'm not sure how effective those were. Demand response was mentioned earlier. Avista does not have a quote demand response resources on our system. However, we do have the capability of buying down some of our loads for economic reasons at times, which we took advantage of during those 2 days. But yeah, our main issue was the distribution system and getting load to the distribution. Now, having said that, on the night of the 28th, we lost a 230 kV bus in central Spokane. Fortunately, that happened at night and not during the day. So that turned out to be a failed breaker, actually a failed 230 kV breaker during a fault. And I think the fault was actually initiated by the failure of the breaker. And this was an older oil breaker, failed internally. Boom, there went the bus. So that was an issue. We ended up operating with that line out of service for the next 3 days. It didn't impact operations, but we were down a 230 circuit in our urban area. The next day, we lost another breaker over in the Coeur d'Alene area. Same type of thing, tripped on a fault, breaker failed internally, oil issue. And you kind of wonder, hey, are these the same breakers? Is this the same failure mode? Did we have a similar issue? What was the issue? We did a pretty thorough investigation on both those breakers and did not find a common failure mode, to be honest. The first time something happens, that's an outlier. The second time it happens, it's starting to become a little repeatable. And then I'll throw the third one in there in the same substation in Coeur d'Alene while they were repairing the first breaker, or replacing, actually, they went and fully replaced it. The breaker 2 bays over was leaking oil, actually expelling oil out of a bushing. So it had not failed. So we ended up taking that breaker out of service as well. So we actually had 3 230 kV circuit breakers during that hot temperature period that we actually took out of service for repairs or replacement. That none of them were unmaintained. They had all been maintained according to schedule. The fact that it had happened at a 109-degree day is suspicious, but none of them were heavily loaded, either during the event or before the event. So it was, I wish we'd have been able to find a more common mode of failure, but we just simply didn't. But I think the biggest issue that we have been addressing over the last several years is Avista's seen some significant load growth 2019, 2020, 2021. I think everybody's aware that there's a lot of movement from certain areas of the country to other areas of the country. The middle of the United States has seen a lot of real estate boom in the last 2 or 3 years, and we've seen some of that. Housing prices in this area basically went up about 50 to 80% over about a 2-year period. It was kind of an amazing thing to watch. And our load, we picked up about 12 to 13% additional load over those 2 years. So that just, that's not the kind of thing you typically plan for as a utility. You're looking at more like, Avista's typical load growth is about 1.5% a year, and that goes all the way back to when they founded the company in 1889. It's pretty typical, very average. You can almost, so distribution planning has been a real focus for us right now. Additional substations, additional feeder capacity, additional transformation down to the distribution level. On the transmission level, actually look okay. Yes.
If I can interrupt you real quick, well, first of all, I've told people Idaho's closed. So your load growth issue on that side of your service territory ought to be okay from here on out, because Idaho's not actually admitting any new residents right now. But that's my standard go-to. I have a question for you. You mentioned that you're learning things as this occurs. And Gary mentioned in his intro that these extreme weather events are not really extreme anymore because they're repeating themselves. And so my question to you is, are we have there been enough of these events, and have they looked similar enough over even just the past 2 or 3 years for us to be able to respond to them better? Because, with RA, to your point of load growth, with RA, what we've been able to do is base what we're doing in the future on what has happened historically. And that is no longer the case with almost everything, right? With generation, transmission, and distribution assets. And so, do you feel like Avista has been learning enough over the past year or two with these extreme heat dome, and whether it's on the distribution system or the transmission system, right? But has Avista been able to learn in order to be able to better respond, say, summer 2023, for the betterment of the reliability of the system?
I would say so. The last 2 years, we've had very targeted work on that distribution system where we had issues in 2021. And we didn't have the kind of heat, obviously, in 2022 that we had in 2021. But, a 100-degree day in Spokane every summer is definitely a positive. I mean, it's just a normal summer. You're going to have a week of 100 degrees and probably 30 to 40 days over 90. So we're about 85, I'd say 90% of our peak load through at least a month and a half of summer. To get to Gary's earlier comment, we do suffer the whiplash thing a bit. We had like the coldest June on record, and then rather warm June and July and August. So there's a couple of moving parts. There's several moving parts here, and this may be more information than you really wanted, Kris, but I'll go ahead and take a few minutes and give it to you. One was that the load profiles have changed, the growth has changed, and I think that's kind of settled at this point. We're back to a more normal year-to-year change. That's one issue. We've, like every other company in the United States, Avista has gone through a fair amount of turnover in the last 2 years, and it really accelerated in the last 2 years. Not so much up until 2019, but from 2021 and 2022, we've had about 12 to 13% turnover each year. And this is for a company that usually has about 2 to 2.5 per year. So a lot of that is people retiring, the baby boomers moving on and that sort of thing. So that's kind of one issue that we've really had to address quickly is, you've seen a lot of institutional knowledge and how do we pass that on quickly? And fortunately, we've had a lot of teachable moments in the last 2 years to help speed that process along. So, but I do think we have changed the way we look at this on the distribution system from how much excess capacity is enough for, as Dede said, a 1 and 2 year. Yeah, a 1 and 2 year, we can meet that, but a 1 and 3 or a 1 and 4 year this is how much further out that tail has moved. And, we don't want to be dealing with these kind of issues every 2 years or 3 years. That's intolerable to most people.
Well, what I think I hear you saying is that we've learned some, but we've maybe not learned enough to react long term to it. But in some of the short term needs or the short term reactions and responses to some of these operational issues. But from a planning perspective, maybe there's more work to be done.
So I'll kind of, I'm an operations person, so I don't look further than a year, right? I will tell you this, I work closely with our planners, and they have made that transition to, hey, we need to, those 10-year plans are not just out there. We need to make sure that they get done and they're on schedule, and they're not done after we've had one of these events, but they're done before they occur. So I would say that from my perspective, yes, we've learned that lesson. It just takes time to get the implementation in place. So, but I think that's where we are today. We're in that transition, definitely.
I appreciate that answer. Yes, you get too technical and I'm going to reel you back in because I'm the non-technical person here, right? So, but I think you're doing great. I appreciate all the detail in that answer. I got you to answer the demand response without even asking directly. I got Dede to answer the demand response, and I know he has his hand up, but I'd really like to go to Rich to ask specifically whether, or Kris, I'm sorry, to ask specifically whether the Salt River project has a demand response component to its RA program, or whether demand response is really sort of a last ditch kind of opportunity to make sure the system is balanced.
Yeah, great question. So we're limited on the amount of demand response events we can call throughout the year. It does play a component in our reserves, in our calculations on a daily basis. If we need to if we're going to call on it, it plays into that. But, you know, we're leaving notification out there at least, I'd say almost 8 hours in advance of that. That was a kind of a question I had for Dede, was from a KISO standpoint, with your demand response program, is it just a standing demand response, or is it you give notification to all the customers, hey, in 6 hours, we're going to call a demand response event?
Yeah, I think this is part of the reasons why I want to raise my hand, because I think, Kris, you asked the right questions about what have we learned, what you know, how much have we learned, and I'm going to go through this a little bit step by step, because we learned a lot from 2020. Many of you know that we have rotating outages back in 2020, and since 2020, we built our lessons learned. We look at what we, you know, what is our strategy, what is our playbook, so to speak. If you're an NFL fans, you know, you have this football playbook, right? For us, it's the same thing. Since the 2020 event, we have a lessons learned, we have a playbook, and we ask the question, what is the strategy? And a lot of the strategies is coming back to what is the risk tolerance of, say, that your customer, your public utility commissions, your state. And if you, here is, for example, if you say that, okay, we want to have a resource adequacy that is targeting for the 1 in 2, which is fine, but then that means that, you know, you're allowing yourself, you know, planning for the 1 in 2, and then you put the planning reserve margin, say that it's 15%, and the planning reserve margin is calculated based on the LOLE analysis, right, based on the expectations of the loss of load. And you say that, oh, my planning reserve margin is 15%. That's because you have some type of an expectations of what the loss of load is going to look like based on that, based on this analysis and the portfolio that you have. Now, one of the options that we have looked at since 2020 is that, okay, we need to increase our RA capacity. But in reality, increasing RA capacity means that you have to build something, right? You have to actually get something. Now, for us, is the RA capacity increased quite a bit by the storage resources. The storage, we haven't talked about storage, but we have a lot of battery. Just within the 2020, we have like 300 megawatt of battery. Now we are at 3,000 over megawatt battery. So that's a lot of capacity. But we are also having these challenges with the fact that hydro. So the hydro drought is actually a reduction for our RA capacity. So as part of this summer playbook, we look at the demand response could be a very quick, you know, capacity, and I mentioned that we have at least 800 megawatt of demand response, and those demand response are limited, just like Kris said. They're limited on how many times you can call per day, per week, and if we do call it, how many hours. But it becomes part of our playbook, and that's why what you are seeing is California ISOs in the day ahead. When we do our load and resource balancings for the day ahead, we can see that, hey, we might want to have an EEA watch, what we call the EEA watch, or we can even declare an EEA1. That declarations of EEA watch and EEA1 would actually send a signal to some of the some other type of demand response, which is we call it the emergency load reduction program. In that emergency load reduction program that is funded and coordinated with the state of California, it actually sent a signal to them, hey, tomorrow I'm going to need you from 4 p.m. to 9 p.m. So we actually make a notifications almost 12 hours ahead of time that we will be using you from 4 to 9. And then when we get into an EA1 and EA2, there is that time notification times, and different programs have a different notification time, Kris, and that's just being baked in as part of our operational planning and operational process from day ahead going into a real time. But really, it's all about the fact that, you know, we are limited unless we build transmissions, unless we build generations, right? Well, really, for supply side, you really have to build resources, right? Generations, battery, or whatever. And short of that, then you use your demand response. And the other one that we haven't talked about is distributed energy resources. Here in California ISOs, we actually have about 2,000 megawatt of distributed energy resources, standalone distributed energy resources, and they all play quite a bit of a role in meeting that resource adequacy for us. So.
And I just want to add, I think that the argument would be right on your having to use demand response because you don't have resources built. The argument for that, counter argument, right, from a prior commissioner's perspective is, did you retire things too early? If right, I mean, if things are being retired early and you're trying to get new generation on the system, but you're having to utilize this demand response program in order to meet that load. I understand that from California's perspective, and I appreciate that that's part of how it's baked in, and I hear you. And I think that if they're meeting load that way and they're able to keep the lights on, which clearly this summer was of great benefit to the system as a whole, right? Because California goes down and we're looking at larger consequences for the Western interconnection. So no argument there, just if the timing is off on getting new generation on, I guess the question is, should we be using demand response? The question of whether we have to in order to meet load is separate from whether we should be utilizing demand response as a almost like front office transaction, right? That the last percentage of load that you expect to be able to serve your customers is from a front office transaction or a demand response program, right? So I apologize for interrupting. I got back in the middle of.
No, it's good, Kris, and I think it's a mindset, right? I'm not a policymaker, and I'm not an economist. I have heard people, but in the state of California, the RA program, demand response, when you think about it, is actually kind of like a preferred resource. You're basically taking the credit from the demand response first before you even consider what you want to build. See, I think that's a different paradigm. When you think about it, resource adequacy credit, which is demand response that is included in there, that's basically a megawatt that you intentionally not built. It's not that we need to use demand response. It's actually the other way around here in this paradigm. It's almost as if we want to include our customer. And one thing that is unique that I think is interesting is that now the customers, I've seen this, that the customers want to be involved. They want to participate, and that demand response does play quite a bit of role. So anyway, that is a very interesting view from state to state. I have noticed that from regulatory authority to regulatory authority, but here in the state of California, demand response is actually taken on the top as a credit.
There's a mindset involved in where demand response, what role demand response has in California and in some other states. I think it definitely, as you said, Dede, varies throughout the Western interconnection.
And playing off of that just a little bit, Kris, coming back to you, as we've talked about this mindset and the playbook, everything else, can you expand a little bit more on Salt River, on how that falls where you're at?
Yeah, great question. Why don't we go back to August of 2020? Let me start there if I can take a little bit of time here. So, it started out, we peaked pretty early in that season. And the heat just kept coming. And I think we ended up with 55 days straight over 110. So it was pretty miserable. I mean, everybody here is very resistant to heat. However, I think after 55 days, yeah, pretty miserable. Pools were more like bathtubs at that time. But with that being said, after every year, we end up reviewing kind of how we've done on the previous summer. And that August, there was a couple of big fires going on, of course, up there in California, which had big impacts. I think that North Complex fire, and then that Giga fire, I think that was the first one, that August Complex fire, that one hit. So we had problems getting energy down from the COI. Then we had our own internal fires happening. We ended up around August, about mid-August, we did a public request for reduced energy usage. That helped us a little bit, but we lost that 500, so we were short and scrambling quite a bit. We did end up in an EEA1 for a short period of time, but didn't have too big of an impact. We didn't drop and shed any load or anything. We were able to get that line closed. The fire didn't damage the line, but the smoke was, of course, getting into causing the lines to trip out. Out of that, we really kind of took a closer look at our resource efficiency and really started doing what we could to secure any additional energy for this upcoming summer of 2021. But we also started rolling into, from a lessons learned stance, we had first stood up our grid incident command structure to try and improve communications and our coordination with the outside agencies. We started working a lot closer with both APS and TEP from a standpoint of supporting each other. We were working a lot with NV Energy as well as CAISO during that whole summer, trying to coordinate better. And then from an after actions lessons learned as well. But, you know, taking all of those lessons learned and just kind of rolling those demand response capability, checking in with other utilities, seeing how they're doing, getting a perception on how the market's looking, seeing what our day is shaping up like, that has really rolled into our active playbook from a real-time stance. I hope that's what you were looking for, Tim.
No, that was great. Fantastic responses. Rich, I'll give you an opportunity as we're talking about the playbooks and everything else with the demand response. Is there anything you'd like to add from Avista's perspective?
So we don't use demand response that much. Like I said, we've got a couple economic agreements with other utilities, but I would not call it demand response. It's not under the control of system ops. It's something we do days ahead. It's also, as far as I know at this point, not part of our IRP, integrated resource plan into the future. We do rely on conservation, which I wouldn't consider that demand response, but it's basically reducing your load growth as much as possible. So, you know, we live in a whole different world than Dede and Kris. It's far colder. You know, sometimes that's our bigger issue. So, no, I guess I probably don't have much to add to that, to be honest, Tim. I wish we had some demand response where I could push a button and drop somebody, but don't have it.
Rich, can I ask a quick question then with regard, because my two sort of big things on here are imports and demand response, right? When we're, in my mind, as we're looking at like heat domes or these excessive heat events. And so the Northwest, of course, is famous for sharing its energy back and forth. The heat dome in, I think it was 2020, didn't really allow the sharing of that energy. And so Dede talked about imports with regard to CAISO earlier. What is Avista's position these days, right? And by that, I mean, in the last year or two, has Avista changed its position with regard to imports and reliance on those imports, those front office transactions? And I will also add to that question, do you believe that the RAP program through the Western Power Pool will put the Northwest in particular in a better position to know how much reliance to put on those imports?
So that's an interesting question. We did see, and I can't recall if this was during the heat dome in 2021 or later in the summer, because actually, if you want to talk about supply issues, we were more concerned late July, early August regarding supply than we were about actual loading issues. They imports into the Northwest, I think in the later part of the summer of 2021 did become an issue, and it was due to some outages along Idaho to the Northwest, if I recall. So that actually did, we were limited on what we could import in certain directions for a while. But our utility is an importer almost all the time. So, you know, we have either remote generation resources that are pseudo tied into a Avista system. So those would be plants that are far away, like Colstrip. Got a gas-fired plant down on the Columbia River. You know, we got a share of the mid-sea. I mean, those are remote resources. So on the balancing side, they're there. From a transmission side, you have to accommodate that. You know, there have to be a system in place to move that into your system. We haven't had issues with importing for resources as far as transmission constraints, not the type of thing that Dede and Kris were discussing. We've had issues with, or at least generally not. assuming the system's most of the systems up, we don't have that issue. My main concern as we move into the peak summer loads is, as an operations individual, you're always looking at N-1 planning. What am I going to do when the next piece of equipment fails? So on the balancing side, the generation side, the resource side, and I don't think we're any different than any other entity. We have some big resources out there, and if they disappear during one of these events, we don't have excess capacity to replace that. So you'll get through the 60 or 90-minute recovery period where you can use your reserve resources and such. But going back to a normal system operating condition could be quite a challenge after that. And we've been fortunate that we haven't had that issue, but I go through every August kind of wondering, okay, get out the EEA procedures, because if this happens, there may not be any market power available to replace this. And in many cases there isn't, or it's very difficult to get. So in that case, we would be in the same position that Dede is describing. We're going to be running down those EEA procedures, hopefully not in a position to shed load, but using load as a resource, to be honest, for the next outage type of thing, which from a reliability perspective is a little concerning. But I'm not sure I answered your question, but.
Well, I guess the one add-on I would make to that is, as you're talking about your ability to import or not and your reliance on imports and Avista's growth that you talked about just 10 minutes ago or whatever,
Yes.
then there's got to be a plan, right? And these things aren't built in a day, and so then our Western assessment, here's a oh gosh, what do you call it when you tell the ending of the story? Part of what our Western assessment of resource adequacy has shown is that the next 4 years or so we're okay. The next 10 years, and by we I mean the Western interconnection, right? The region as a whole. The next 10 years, it doesn't look great. And so is that kind of Avista's outlook on this thing? And then what about those times when you're stuck, right? What is the reaction of the utility to that? And I would also add to that, from my former commissioner perspective, right? How do you convince commissions that have to allow for recovery of costs? How do you convince them that this is necessary? What do you have to show to them? If you only have 2 years of data, is that enough to convince them to allow recovery of costs for these builds?
So we're facing the same challenges everyone else is. Coal retirements were mentioned earlier. We have a share of coal strip, a rather large share of the coal strip plant in Montana. So we'll have to replace that resource. And so at the same time, you have resources disappearing, you do have load growth. You still have to replace that and then additional, as you said. Fortunately, I don't work on the supply side of the business. So I don't lose, I lose sleep over it when it's happening, but thinking about what it's going to look like in 10 years, I got a whole other host of problems. I will tell you this, when we do look at our operational profile for the upcoming year, assuming supplies are adequate, and we do talk to our power supply group about this, as far as how we operate the transmission system and what we expect to be able to carry reliably, we typically pick our last all-time peak, which is about a 1 in 5 event, and we add 2 to 3% load growth on top of that, which is fairly typical. And so, when we do a winter or summer study, we're already way out on the expected peak. So from a transmission perspective, we may have some concerns, but we know exactly what to expect if things get very, very dicey. So import capacity, that sort of thing, we're looking at that and we're comfortable with that. The resource side and the resource adequacy issue, I'm looking forward to seeing how that plays out in the Pacific Northwest, as that program gets underway, and how entities will share the adequacy piece and how they'll ensure that the region as a whole is healthy. There's a lot happening there, and I've followed it, but I'm not intimately knowledgeable of it, I'll admit.
I love the answer of that's that guy's problem.
Oh, well, we all have our areas of expertise, right?
For sure. Gary has a question. Yes, sir.
First, a comment, Rich. Appreciate your remarks. Although I think I'd suggest you rotate over to the resource side of the organization so you can get a little bit more familiar with it and have some footprints there. Question on back on demand response, and maybe for Dede particular, or Kris. It seems to me at some point on voluntary actions, and I know, Dede, you had sort of success, if you will, with some pretty significant voluntary cutbacks from a load perspective without having to, get into further levels of reduction. What do you hear from the customers? I mean, is there a pretty good tolerance for this at this point? You said customer support is good. I think we've grown up in this country with electricity being a God-given right or something, as opposed to the way we look at it from an operational standpoint. So I wonder at what point the customers are going to say, wait a minute, that's enough of this. And, we need to go to plan B and figure out a better way to keep the lights on. So I appreciate your reaction on that, guys.
Yeah, I think maybe I'll start just a little bit tidbits on the number here. So when we talk about demand response in California, it's a large chunk, right? So there is a contracted demand response that I mentioned is actually included in the resource adequacy capacity. Those are actually contracted, so somebody has payment out of that and whatnot, and is actually have obligations. And so when I said about 800 megawatt of demand response, it's actually pretty. In the operation, it's kind of pretty cool. I hit the button, and it's actually not me. I guess the system operator hit the button, and it actually gets out, and we actually get 800 megawatts of reduction. So that's really cool. We actually do have emergency load reduction program. Those are, we kind of call it demand response, but really it's a load reduction program in the sense that they're actually behind the meter generations, right? These are behind the meter, thermal unit or backup generators and whatnot. So when you call on it, it's actually running. So nobody's actually losing air conditioner, so to speak. Now there are some aggregator that is really cool that they sign up and then they allow some aggregator to actually move the needle on their thermostat to get 78 degree. And honestly, I mean, I always run my thermostat at 78 degree anyway, so it depends in there. But there are some voluntary demand response. So that's some of the thing that is, well, in California, we have a program that's called Flex Alert. Flex Alert is actually just, telling people that, hey, we're going to have a Flex Alert. And honestly, this particular year is the longest that I have ever seen on the heat wave. It started from August 31. It goes all the way through like September 7, 8, 9 maybe. And there is if you look at the social media and the Facebook and the Twitters and the YouTube, there are some fatigue because people are just saying that, hey, why are you asking again and again and again and again for this voluntary? But we did see that people, the California folks, are actually chipping in. And on the September 6th, we at least know that there's like a 500 megawatt voluntary demand response that is out there, and even more. And you probably heard that the governor of California and the state coordinated this wireless messaging where it actually shows up in everybody's iPhone that says, hey, or everybody's phone that says, hey, we're actually in EA3 reviews, and we get quite a bit of response from there, and those are voluntary. So we have all type of demand response. There's demand response that is actually contracted for resource adequacy, and there is demand response that is emergency. And I didn't even mention there is actually what we call a proxy demand response, and that's our actually demand response that is voluntarily, but is actually bid in the market. So we have about 500 megawatt of that actually working, where they got paid in the energy price, not the capacity, but they get paid energy price at the 500 megawatt, quite a bit of that. And customers helps a lot. And I think this goes back to what I wanted to touch upon a little bit. What Kris was asking is, I'm not a policymaker. I'm not an economist. When you have a load profile like in California, where your load is normally 45,000 at the most, right? 1 in 2, 45,000, and once in a while you get to this 52,000. The question is always that economist people was asked is like, is it worth investing a gas plant unit or even a battery for that period of time that I might need it once, 1 week out of a year? Or do we just contract it with distributed energy resource, contract it with demand response? Because those are an economical decision and customer rates impact because the load profile in California, like in today, our peak load's probably like 27,000, 28,000, 30,000, and we rarely get to that 45,000, let alone the 50,000, 52,000. So, it's what is the risk and the tolerance. But like you said, though, Gary, if you get like 7-8 days worth of a heat wave, the customers would be asking, why so long of a flex alert? Why so long for that ask for a voluntary demand response?
Yeah, thanks, Dede. The other thing I would add while I have the mic here is some of you may be familiar with other parts of North America, but up in Ontario, they revised their retail pricing structure, and they basically have time of day rates. And over the past 5 to 7 years, Ontario Hydro has been very successful at moving the peak, because if you send a pricing signal to people where you're going to pay twice for electricity what you would do for, in the off-peak periods, people do change their behavior. So that's another alternative. We haven't done much of that in the U.S., but I'll throw that in as a possible alternative as well. I think when you have contracted demand response and there's economics involved, I think people will respond. It's the one I worry about is when we just ask you, please not use electricity and hope for the best. That's not a real good strategy. So thanks. Back to you, Kris.
Well, I'm not sure which Kris you mean,
Yeah.
but I know that Kris from Salt River Project didn't have an opportunity to chime in on this, but I would add to Gary's comments also that I think that some of this is like turning the Titanic, right? There are mechanisms, right? There are time of use rates that some of the utilities within the West use. It is difficult to get utilities don't know exactly what to put in front of their commissions that's going to get approved one way or another. And you don't know if the commissions are willing to consider other mechanisms. I know that rate design has been a huge source of contention for years now, right? Within NARUC, the National Association of Utility Commissioners. And it's like turning the Titanic. I agree that there are mechanisms which could be utilized to be helpful in these circumstances. And so part of why we have this dialogue, right, is to pull some of those people into this conversation so that everyone is on the same page, so that utilities can go to their commissions and ask for some of these things, and that the commissioners and the staff at those commissions feel like they've got the benefit of some additional information, right, for whether it's regional or national, in order to be able to feel confident in making these decisions. But the difference is that over the long haul, they haven't had to turn on a dime. That hasn't been the way that the industry has been. And so there's this mindset in the industry where it's really hard then to be like, nope, we're changing it here, and hard stop. And so maybe it is that we all need to be a little bit more nimble in order to be able to react the way that the industry and the customers are needing us to react at this point. But I'll push it to Kris Hofmann to answer more directly on Director Leidich's question as well.
So it all depends on if I'm home first or my wife's home first. If she's home first, yeah, that's getting ignored. But from my perspective, it works the opposite. We've had really good success with our residential customers as well as our commercial customers. Our team gets out way ahead of time and does a lot of educational programs as much as possible on energy conservation, on utilizing demand response, why we do it, what potentially calls into it, or what calls it into effect, and how it helps everyone else. It seems to be it works pretty well in the short term, but if you see multiple days, kind of like Dede touched on, you will see a reduction in that. And it can be challenging to some of our larger, the commercial demand response, where it's impacts in multiple days in a row. We really try and avoid that. But overall, yeah, we've seen a really good success rate in that, especially on those emergency type days that Dede described earlier.
Well, thank you both, Chris's. Chris Vapor, you made a great comment. Although I'd prefer to call this a battleship rather than a Titanic. It is very difficult to move the industry. And I'll give you a couple of data points and then I'll shut up. But here's a data point. We have 1 million megawatts of generation in the United States, and we generate about 4 trillion kilowatt hours every year in the United States. So the numbers are huge. The scale of what we have to deal with is massive. And I think our pace of change over the years has been a lot slower than the pace of change of what we're talking about today, which is the weather and the climate. So that's why we're going to have that flexibility you're talking about. Thanks.
I'm going to use battleship from now on because the Titanic went down and that is not our goal. So I appreciate that modification, Gary. I also want to make sure, we're coming at the end of our hour and a half. We're getting into the last 20 minutes or so. Anyone on the call who is listening in who has any questions for any of our panelists or speakers, moderators, whatever, whether it's Gary, me, or Tim also, then please put your questions in the chat and we will address them with our panelists as they pop up. And I'm going to push it back to Tim because I know that he had this framework for leading a discussion, and I'm not sure how far afield we got, but go ahead, Tim.
No, you're fine. For the most part, as we're moving around, we're hitting those topics and it's great. So what we're going to do is talk about a couple of things just to make sure we're talked about everything as far as everybody on the panelists wanted to say. But again, feel free to use the chat, as Kris said, to ask any sort of questions, anything else. We want to make sure that gets in there. So make sure you get those questions in soon. At the same time, I'm going to use the chat and I'm going to post a link to a document because I want to make sure that everybody is aware from the 2020 heat wave that occurred. WECC did do an analysis of that. And at the time, there were certain lessons learned that we had from it. And everything else. For instance, one thing, when we looked at it all, we had the demand response. It was about 5,000 megawatts or so as far as what was provided to us on the day and the time that we set at the time, the new interconnection peak record back in 2020. Now, granted, we've did it again today, and based on the information we've gotten so far, it wasn't as much. For 2022, we're about 1,650 megawatts in demand response that was used at that time. Again, we're still waiting on a couple of more responses from some of the entities here in the West to true up those numbers, everything else. But one question might be is, well, why were the two so low? Well, the 2020 heat wave really did impact more the interconnection on a widespread level. You heard Rich Hydzik mention that a little bit as well, that the more impact widespread something like this makes generation a lot more tight, and we've got to use more of those resources in it. Whereas this last September, it wasn't as much. People felt it, were impacted by it, but they were able to get by without having to go into those EEAs, as we mentioned before, and everything else. But one thing I do want to touch upon that Dede also said is within that report, you'll be able to see down at one of the last pages, a chart that shows the actual demand versus forecasted demand. And one of the terms we heard at the time was how the demand response really trimmed things down from what was forecasted. And there was concerns of whether or not it would look like what is called a volcano, basically trimmed down, but was it then going to explode as everybody just, didn't use it as much or anything else, and it would just kind of take off. So one of the success stories out of these is everybody doing those reductions and everything else and helping the entities meet these demands. This is definitely one of those success stories out of that. Now, there's a lot of lessons learned that we can come out of this as well, and I want to make sure that which we have an opportunity to make sure that which we've highlighted those. So Kris, I want to go with you a little bit from the 2020 to the 2022. Especially, what were some of those lessons learned that you've experienced in the 2020 that you've been able to implement and help you out for all those heat waves since then? Feel free to share.
Yeah, absolutely. So we touched on the grid, the introduction of the incident command structure to improve communications both internally, so we're all on the same page, but also from an external standpoint, really got some more information out to the customers, tried to get in front of them much more, a lot more coordination with not only internal Arizona utilities, but neighboring BAs, as well as working with the RC West from a summer preparedness and looking at any challenges to that. A lot more increased coordination with the fire agencies as well as the Forest Service, trying to point out, lessons learned from other states, what they've seen from an impact wise and how best to avoid those. And then moving from that, what we're moving towards more is putting all the utilities together and running through last year's challenges in a tabletop type scenario, which really seems to help prep the operators and get us to identify any potential challenges or shortages where we may be lacking.
Thank you. Dede, asking you that question from the 2020 to 2022, what were those additional lessons learned and what have we done?
So, well, first of all, I think the geographic diversity on the extreme heat is still a little bit different between the 2020 and the 2022, right? Because in the 2022, I think the Northwest has a little bit more hydro. So we're locked out on that one. But I think number one is we did have an increased capacity through our resource adequacy procurement. So comparing to summer 2020 to 2022, we actually have about 3,500 megawatt of lithium-ion battery storage. So that allows us to move the energy from the high solar days to the net peak. So that's number one. We have 3,500 megawatt, I think, extra or not extra, additional battery storage. And number two, I think what Kris mentioned is that we do have enhanced coordinations with all the load serving entity and the neighboring BA, and so we could actually have provided emergency assistance. California ISO was providing emergency assistance to other BA, and we are also receiving. So that's kind of interesting. People was asking, was like, well, I thought you were short. Yeah, we were short, but we were also providing emergency assistance to others, and it just did different on the timing, right? Because we were concerned more on a net peak. We were not concerned about the gross peak at all, because the gross peak we're fine. So that's the enhanced coordination. But we also have an enhanced coordination, awareness, and communications with the state agency, the Public Utility Commissions, the state agency, the publicly owned utilities within the California Energy Commission, the Governor Office. So that close coordinations and allowing us to have the playbook as we when do we do what is really spot on, and it's really good. We also worked with our what we call the enhancement of the clarity of the import, making sure that we can, if we do have an import, we know what is the priority of the import that we're getting, so we have a bit of clarity, because that's one of the biggest challenges with people. We are relying on import, and I mentioned that we have about 4,000 megawatt import of resource adequacy import, and others may have also import in there. So anyway, having that clarity of what is the priority and how high is that scheduling priority on the import, it's really helpful. And of course, we are also having this the fact that we have the clarity of who does what when it comes to communications with the public, and getting a clarity of what we need of the public to do, because there is a lot of power that the public can actually do with regards to managing the load. So that's a big chunk of the lessons learned. There's a bunch of trainings, coordinations that is in there that we always do anyway, but the biggest portions is those items between 2020 and 2022.
Thank you. And Rich, I know you've shared some already. Do you have any additional lessons learned from the 2021 and other heat waves?
I can only say the lessons I've learned over the last 5 to 7 years is there's no such thing as extreme weather. It's just weather at this point, and just get you. I mean, just look at what we're talking about: 2020, 21, 2022, 3 years in a row, same type of event. That's like a yearly thing at this point. That's not out of the norm at this point. So weather for whatever reason, if the weather's changing or it's moving to a new norm, you have to plan and operate and build to that. So this, to me, this is a far more of an engineering problem than anything else. But I don't know. That's probably not helpful. That's the operator talking here. So I'll mute again.
That's fine. I do want to let other people know too. So WECC has been looking at the 2022 heat wave to try to compare that to the 2021 report as well. But one thing that which we have noticed so far in some of the data we've looked at is the wind generation during this time, especially as the heat is there and at the peak of the time, the air becomes more stale, whereas wind generation is usually typically lower during this peak time. So I do want to make clear that I'm not trying to make any sort of emphasis on one type of generation over another, but just bringing the fact that the wind generation may be lower during this time. And so that's one of the things we need to plan on as we continue to move forward, playing off of what Rich said. This is kind of a normal thing. We've seen it for the past 3 years. And based on the analysis we were doing and observations so far, the 2020 and the 2022 heat wave data does show us that the wind generation may be lower, and we need to plan accordingly for some of that stuff. So that being said, Kris or Gary, do you have any other questions for our panelists?
Just one I would have, and maybe it's for Rich, but certainly the others as well. You talked about the extremes becoming the normal, and I really kind of agree with that. Are your planners looking at this differently? In other words, have you sort of moved the boundary conditions and changed how you look at temperature maximums and stuff like that?
Yeah, we have. The summer peaking loads they're expecting, they're looking at more like a 1 in 5, 1 in 6 rather than a 1 in 2 10 years down the road. And the other thing that we haven't talked about at all, but cold hasn't gone away.
Right.
I think, Gary, you mentioned Texas in your opening remarks. We have a new EOP standard in the last couple of years because of a southeast cold event in 2018, plus Texas. So, extreme cold hasn't changed. And we usually see those cold winters in our area about no more than every 5 or 6 years, and we haven't had one for 5, so I'm kind of expecting a pretty cold winter, or at least something like that this year. So I think we need to understand that the pendulum, just like you said earlier, it swings both ways. And if you plan for summer, winter might surprise you depending on where you live. We saw this all the way back to 2010 in the Southwest. So
I love that Rich is the one guy on the panel that has a dual peaking utility, right? It just occurred to me when you said that, Rich, that, oh yeah, right? The whole polar vortex thing that Gary talked about in the intro is a part of your reality. I remember the ice storms that Spokane and the whole northern area of Idaho as well experienced not all that long ago, and the ability to react or respond to that kind of a situation. So sorry, I don't want to stop the other panelists from answering Gary's question.
Yeah, we're studying it as well out with the extreme changes. We're kind of curious to see if FERC 881 will have some unintended benefits of maybe providing additional visibility into that as we're working towards implementing that. So.
Dede, what about Cal ISO? Are you guys looking at the extremes becoming normal?
Yeah, so there are a few ways of doing this, right? This is probably more detail that we want, but the load forecaster, the resource, the resource folks that is within California ISO keep telling me and keep educating me that it really depends on how many years of samples are you using. So for example, our managers of load resource adequacy, I think he's probably listening to this as well. He's always telling me and reminding me that, Dede, if you actually do 1 in 2 and you look at 20 years worth of data, it would actually be very different than you are looking at 1 in 2 in the last 7 years worth of data. So just looking at the fact that if you want to have the sample of 20 years versus the sample of 7 years over the sample of 5 years, your definition of 1 and 2 becomes different to begin with, right? Then when you start asking, okay, when we are doing the 1 and 5, for example, it's the same thing. How many samples of data that you are using, and if we've actually looked at that, and we do our own resource planning we do our resource assessment, and that's one of the things that we do. We look at the probabilistic analysis. Now, of course, the probabilistic analysis is actually really it's harder to explain, but you are looking at the probability all kind of hours in the year, and the reasons what I mentioned that is not just about the extreme heat or extreme event that we've been having more often, which is taking you the scale of how many years of sample data that we need to actually look at, but also the fact that of the matter is that when you start looking all this at this event that we are having, then you actually need to look at energy sufficiency. I think NERC and WECC's been talking a lot about energy sufficiency and not just looking at the capacity. And because at the end of the day, you have a very different hourly energy profile, and I know that California has been looking at different paradigm for resource adequacy, where you don't just look at the gross peak, you don't just look at the net peak, but you're looking at every hour of the day, and do you actually have a resource sufficiency for that? Because extreme event or heat is one thing, but also the shape of the heat, the shape of the load now becomes changing, like the tail end of the loads and the shifting of the load itself is also changing, and a lot of that is because of our rooftop solar and the behind the meter rooftop solar, but so there is a lot of mix there that is luckily we have all smart people everywhere working together to figure out how best to tackle that. This is when I always tell people that luckily that I'm not an economist, I'm not a politician, I am an engineer and an operator by design. So I'm relying on everybody else to solve the problem together.
So I love that Dede advertised or put out there the way that WECC is looking at this, which is based on energy. And we agree, it's every hour of every day, right? You can't compartmentalize the way that we used to compartmentalize those things. And so thank you for pitching the way that WECC is, has begun to look at this. And I think that all perspectives are beneficial and we learn a lot from the different views. But I think that that's a really valuable one as well because of the change in the load. We are running up to the end of our hour and a half. I want to greatly thank Gary for starting us off. He is always a great contributor as a director for WECC, and so we thought it would be really valuable, as it has been, to have him as part of this discussion. And Kris and Rich and Dede, always a pleasure. The highly technical stuff is often beyond my purview or understanding, but I think for the most part, I was able to follow the discussion today. And I think that for a narrow topic, right? Heat domes, heat waves, heat events, whatever you want to call them. There's so much more to have a conversation on, right? There's such a broad range of what can go on and ways that we can respond. And I think probably the lesson learned is we all need to be collaborating and talking with one another, which I think I heard each of you say, because talking with one another allows us to plan better. And that we need to be planning for what used to be extreme but is no longer extreme. And so I think that we need to consider that the historic perspective is probably not and hasn't panned out to be what the future perspective is going to be on things. And we're going to have to make some hard choices for how it is that we keep the system reliable. I want to do one last pitch for the release of the Western Assessment. It went out today in emails. I think it's available on our website. I want to thank Tim for co-moderating this panel with me. I think it's been a great discussion. And I'm going to pass it back to Travis in case I missed any of those important highlights at the end of the presentation.
Great, Kris, thank you so much. I appreciate it. And I echo the gratitude and thanks to the moderators, Kris and Tim, thank you. And Kris, Richard, and Dede, I appreciate you guys taking the time to come on and share with us. And Director Leidich, appreciate you as well. Up on your screen right now is the Resource Adequacy Discussion Series survey. We're surveying our stakeholders and hoping to get the feedback from you as we continue the discussion series into 2023. We are taking a pause next month on the conversation, but we're looking for feedback as we continue, and we want to hear your thoughts on the past 5 discussions that we've had, and as we plan the series going forward. And then one more plug for the Western Assessment of Resource Adequacy. You can find that on WECC's website, WECC.org. I think the link's going to go into the chat there. As Kris mentioned, it was released today. And we are holding a webinar next week, November 9th, same place, same time. So it'll be at 10 a.m. Mountain Time, where we'll be discussing a high-level policy overview of the Western Assessment of Resource Adequacy. So with that, we've hit the time for this morning. Again, want to thank all of our panelists and moderators, and thank you as the audience for joining us this morning, and hope you all have a great day. Thanks, guys.